All right, here we go with lesson 4. Again, it's going to be similar to 5.3 because we're still dealing with the sum and difference identities. It's just that now we're going to be talking about sine and tangent, right? In lesson 3, we talked about cosine, and now we're kind of rounding it out with these other two. The sine identities are very similar to the cosine identities. So the sine of a plus b is sine a cosine b plus cosine a sine b. So in this one, the addition makes sense with the sum. However, the cosine and sine are together instead of cosines together and sines together. And then the difference is exactly like the sum. It's just a subtraction in the middle. So we have sine A cosine B minus cosine A sine B. The tangent ones are a little bit more complex. So tangent of A plus B is tangent A plus tangent B over 1 plus tangent A times tangent B. And then here we have tangent A minus tangent B over 1 minus tangent A times tangent B. So take a moment, make sure you have those written down, and we are going to use these to complete the examples. All right, sine 75. Again, if you don't have your unit circle nearby, you might want to grab it. We want to be able to figure out how we can get to 75 using the angle measures that we have. So right away, I see, hey, we have 45 and 30, and I know that if I do 45 plus 30, that gives me 75. So this is sine of 45 plus 30, which means I'm going to use my sum identity. So everywhere there's an A, I'm going to put 45. Everywhere there's a B, I'm going to put 30. So we're going to have sine 45 times cosine 30 plus cosine 45 sine 30. And then we just grab those values from our unit circle. Square root of 2 over 2, square root of 3 over 2, square root of 2 over 2, and 1/2, which gives me square root of 6 plus the square root of 2 all over 4. And like I said in the lesson 3 video, a lot of these tend to look very similar with the square roots and the 4. All right, not gonna lie, this one's a little bit of a doozy, but we'll get through it. 7 pi over 12. All right, we got to figure out how to get 7 pi over 12. And this is one of the reasons why I rewrote all of those radian measures in twelfths, because when it's like this, for me, it makes it a lot easier to see what two angles I need to add together to get to 7/12, right? If I just have this, it's not as obvious, but when I have this written out here, I can see, 4/12 and 3/12, that's going to give me 7/12. So I know I need to do pi over 3 plus pi over 4. So this is the tangent of pi over 3 plus pi over 4. And then, excuse me, I'm going to use the identity. So we have tangent pi over 3 plus tangent pi over 4 over 1 plus tangent pi over 3 times tangent pi over 4. And again, I'm going to pull these values straight from our unit circle. So tangent of pi over 3 is the square root of 3. Tangent of pi over 4 is 1. So this gives me the square root of 3 plus 1 over 1 plus, this is the square root of 3, whoops, 1 plus the square root of 3 times 1 is still just the square root of 3. Now, this is not quite simplified. We have to rationalize the denominator. And a way that you will see often to simplify expressions is to multiply by the conjugate. So we are going to multiply by the conjugate of the denominator. Multiply by the conjugate of the denominator. So the conjugate of the denominator is 1 minus the square root of 3. And whatever we multiply to the bottom, we have to do the same thing to the top. And the reason we do this is because when we multiply conjugates together, what we find is that things tend to simplify, things like square roots. So now we're going to go through and FOIL. So square root of 3 times 1 is square root of 3. Square root of 3 times the square root of 3 is 3. And if you're not sure why, square root of 3 times the square root of 3 is the square root of 9, which is 3. And in fact, anytime you multiply two square roots together, you're just going to get that thing that you're multiplying the square roots of. So square root of 10 times the square root of 10 is 10. Square root of x times the square root of x is just x. So we did square root of 3 times 1 is square root of 3. Square root of 3 times square root of 3, I get that minus 3. 1 times 1 is 1. 1 times the minus square root of 3 gives me minus square root of 3. Okay, then here, oh shoot, you know what? I just realized I messed up the identity. This needs to be a minus here. I'm sorry, guys. So this is a minus, and this is a plus, which is going to change things a little bit. So that's a minus. That's a minus, which means that we actually need to be multiplying by 1 plus the square root of 3, which is going to make all of these positives. So sorry about that. So make sure you got those changes there. Tangent A plus B is a positive on the top and a minus on the bottom. Tangent of A minus B is a minus on the top and a plus on the bottom. So pause the video if you need to. Make sure you have everything matching what I have. All right, I'm going to multiply out the bottom. 1 times 1 is 1. 1 times square root of 3 is square root of 3. This gives me negative square root of 3. And this gives me minus 3. Okay, now this is why we multiply by the conjugate, because now the square roots on the bottom are going to cancel out. On the top, I have 4 plus 2 square roots of 3, because I have a square root of 3 plus another square root of 3. And then on the bottom, I have negative 2. I can simplify this because everything has a factor of 2. So this becomes negative 2 minus the square root of 3. And that would be our final answer. So it gets a little messy there with the conjugates and that sort of thing. But that's how you use the tangent. All right, Part C, this one's a little bit easier than the tangent one, I will say. We did one like this in lesson 3, where you're basically given an identity and you have to kind of work backwards. So it goes sine, cosine, minus cosine, sine. So this is the difference of signs. So if this is A and this is B and A and B, this is the sine of 40 minus 160, aka sine of negative 120. Well, negative 120 is coterminal with 240 because if I add 360, so sine 240, use your unit circle, sine 240 is negative square root of 3 over 2. All right, moving on. Write each function as an expression involving functions of theta. Okay, so this again is just plugging things in. This is a A and a B. That's a difference. So we're going to use our difference identity, this guy right here. Everywhere I see an A, I'm going to put 30. Everywhere I see a B, I'm going to put theta. So I have sine 30, cosine theta minus cosine 30 sine theta. So that gives me, what's sine 30? 1/2. Cosine 30 is square root of 3 over 2. And that's really about as simplified as we can get. You could, if you wanted to, write it as one fraction, so you can leave it like this, or since they both technically have a denominator of 2, you could write it like this. And one way is not necessarily better than the other. It's just good for you to recognize that these two things are the same, that they are equivalent. Because a lot of times you'll see, especially on like multiple choice answers, and this is good for things like the SAT or any sort of standardized math test that you're going to take, the AP Calc exam. You might have a certain answer, and then you look at the multiple choice questions, the options, and you say, well, none of these answers look like my answer. And you kind of get discouraged and you think you did the problem wrong. Well, it's not necessarily that you did the problem wrong. It's just that the correct answer looks different than the answer you have. So it's just good to be able to move things around and recognize that you can write things in different ways. All right, what I'd like you to do is pause the video and try parts B and C on your own. All right, so for part B, I got 1 minus tangent theta over 1 plus tangent theta. For part C, I got negative sine theta. All right, I am going to make this into 2 parts. So take a little break, come back for the next video where we'll finish up the lesson 4 notes on page 17.